All right, so I promised you an easier way of differentiating, and this is going to be it. So we have so far looked at derivatives by first principles. We're now going to have a look at derivatives by rule. So you can see here I've got a table, and these are all the rules that you can use in differentiation, and this is kind of what the methods 4 looks at. We will not be doing all of these. We will literally only be doing the first one in this course, but I just want you to be aware that there's lots of different rules for lots of different situations. Okay, so we can use these rules, and the one we are going to use is on your formula sheet under calculus. We're looking at differentiation. So this rule here, it looks very complicated. It's actually very, very simple, and we'll go through that. But we're looking at that one there, differentiation. So what we need to do to be able to use the rule is split the function into its terms, okay? And we will differentiate each individual term. So for example, this one here, we've only got one term. We'll only have to do one thing. Here we have two terms. We'll have to do each term separately. Here we've got 3 terms. We'll have to do 3 terms separately. Okay, so we're going term by term. We're not looking at the overall picture. We're going term by term. So let's try the first one, and we'll talk through this rule. So you'll see here that the rule is written twice. It's written once with, let me just change my colour pen, with f of x, and it's written once with y equals. Now you've seen that before. Functions are notated with f of x or y. It's just two different mathematicians that invented it at the same time, couldn't agree on anything, so we have two different notations, but they mean the exact same thing. So if you differentiate an f of x or g of x or whatever, you use f dash x. If you differentiate a y equals, you use dy over dx. Okay, they're exactly the same thing, and we do the exact same thing with them. So this rule here is actually the same rule. Okay, it's just written twice with different notation. So let's have a look, and we'll try and differentiate this function here. So we've got an f of x, so we're going to use an f dash x, and we're going to write it kind of like this. So it's kxn, so k is 1, x, and n is 8. Okay, so the n is going to come down the front, and it's going to multiply the number in front, and we're going to take 1 away from the power. Okay, so the power comes down the front, and you take 1 away. So power comes down the front, 8x, 7. Okay, so the formula is actually more complicated than it is. So if we had x to the power of 9, the 9 comes down the front, take 1 off the power. If we had x to the power of 16, power comes down the front, 1 off the power. Okay, if there's already a number in front of it, like 2x to the power of 4, the number comes down, the power comes down the front, 1 comes off the power. So this would be 8x to the power of 3. That's all that's saying. So the power comes down there, it multiplies by whatever's in front of the x, if there is something in front of the x, and you take 1 off the power. Okay. I think the best way to understand this is to do a lot of examples. So this video is going to go through from quite easy to quite difficult. If you want to stop it here and try for yourself, that's fine. And if you want to watch a couple of the examples and then pause, that's fine too. Okay, if you're not feeling confident, watch it all the way through and then let me know if you need help. So this one has 2 terms, so it's going to be a little bit different. We've got one term there and another term there. So we've got 7x and -4. So we're going to do this in 2 parts. We're going to do each term separately. So I've got f of x, which becomes f dash x. Now 7x. So we want to look at the power of the x, which in this case is 1. We times the power by the coefficient. 1 times 7 will give us 7. And we take 1 off the power, which is 0. Okay. If you remember back to the start of the year, anything to the power of 0 is just 1. So that x actually disappears completely. Okay. So that's our first term done. Power comes down, multiplies the coefficient, power gets reduced by 1. Now we've got to look at this next term. Now that term there is a constant. It doesn't have an x there at all. So we're actually just going to get rid of it. Okay, it doesn't have an x. We don't include it in the differentiation. So if f of x is 7x minus 4, the derivative of that is just 7. Let's try another one. This time we've got 3 terms. Okay, so we've got f of x. We know that our derivative is going to be f dash x. And we're going to go through and we're going to do these 3 terms separately. So here, 2 times x squared. We're going to drop the power down to the coefficient, which will give us 2 times 2, which is 4. And we're going to take 1 from the power. Okay, we're going to times the power by the coefficient, so negative 4. And we're going to take 1 off the power, which leaves us with x to the power of 0, which disappears. Okay, don't worry about the constants. Constants just disappear. So the derivative of this one is 4x minus 4. Can you see how much quicker this is than first principles? First principles, we'd have to do that f of x plus h. We'd have to expand that out and do all that cancelling. So rules are much quicker once you get your head around them. All right, let's get a little more difficult. So we've got f of x. Again, we're going to use f dash x as our notation. Power times the coefficient is going to be 20. Take 1 off the power is going to be x to the power of 3. 3 times my fraction, so I can do this 2 ways. I can go 2 over 3 times 3 over 1 equals 6 over 3 equals 2. Or I can go 2 over 3 times 3, those 2 cancel out 2. Okay, so that's just your fraction practice there. So here it's negative 2, and we take 1 off the power. And then the third term, so we're doing these separately. We got power times coefficient is 7. Drop 1 off the power, gets rid of our x. And that's our answer there. All right, this one here we're going to do 2 separate ways. The first way I think I'm going to expand it. And then the second way I'll just do it from that. So f dash x is our notation. I'm going to expand it out. So x squared minus 4x plus 4. And I'm going to go term by term. So first term, power times coefficient is 2. Take 1 from the power is just x. Power times coefficient is negative 4. X disappears. And there's my answer. Okay, that's a way of doing it. That's fine. Either one, I don't care which one you do. But another way would be thinking of this as one big term. So the power times the coefficient would give you 2x minus 2 and 1 off that power, which is 1. And then you just expand that out. So 2x minus 4. So both ways are fine. They're both about the same length there. If you got one that was like x minus 2 to the power of 8 or something, the second one would probably be a quicker method. Either one's fine. All right, this will be our last example. So this one here, everybody hates fractions, so let's try and get rid of the fraction first. So I'm actually going to leave it as f of x because I'm not finding the derivative yet. I'm just simplifying. So we're taking an x out of that one, which gives us 3x squared. Taking an x out of that one, which gives us 2x. Taking x out of that one, which gives us negative 5. Okay, every term has to be cancelled down like that. You can't just knock one x out and leave it. So now I've simplified. Now I'm going to find the derivative. Power times the coefficient is 6. Take 1 off the power is just x. Power times the coefficient is 2. Here we don't worry about the constants. So it's 6x plus 2. So a lot quicker than first principles. But make sure you practice first principles because I can almost guarantee it's going to be in your assessment in one way or another. Okay, but hopefully rules are a lot quicker.